All right, let's start with some announcement reminders. Your Lab 0 Part 2 that will mark the end of the review tutorial, it will be due tomorrow, Friday, and make sure 12 noon, the same deadline as last week. And make sure to submit in time, no late submission will be accepted. And then your lab number 1, which will be a brand new lab, which will involve a lot of stuff to be built on your own. That one is going to be released shortly after the deadline. Hopefully, maybe just after lunchtime, after that. And if you go to the study site, you can see that under here, oh, yeah, there we go. Under here, I posted the material from the in-lab demo from yesterday. It's kind of optional, but for those of you who might need more intuitive sketch about how the programming pattern works, it's going to be required for both the labs and also the programming tests. You might find them useful. Just watch one of them. You don't need both, just one. They're basically the same. And then today, I don't have the office hour. It's going to be rescheduled. Maybe not to tomorrow, maybe to sometime next week, because you will be a little bit struggling with lab number 1. So maybe you'll be wiser to really have the extra office hour next week. I'll let you know when that will be, but not today, sorry. And this is important, okay? Let me show you what I really mean by mock-up programming test, okay? It's really for your benefits, but let me just explain the rationale over here. If you look at the semester calendar here, all right, we are over here on Thursday. We are here, right? Your very first programming test is going to be October 9th. Still seem to be distant, but I think it would be nice for you to kind of get a feel about what a programming test is like in the lab test mode. So what I would do is this. I'm going to release, maybe over the weekend or maybe tomorrow, I will see. I'm going to release the programming test guide just to let you know the rules and etc. Rather than releasing the practice test to you right away, why don't we have you take it almost like a lab test environment, give a try to see how well you might do. It doesn't count towards your grades, but I can give you very nice feedback about how nervous you might be or how stuck you might be, so you can still do something about it before the actual test. So having the mock-up test on 25th is not a good idea because the scheduled lab session, you may have questions related to your lab number 1, so I wouldn't put it there. Instead, our best option, it will be 27th, next Friday. And the only time they have available there to really accommodate the class will be 5 p.m. and 6 p.m. So I'm going to run 2 sessions there. Optional, if you just want to come to the lab and do the practice test for the very first time, and you can come. Optional. If you don't want to come, if you cannot make it, you can still take the practice test a little bit later and simulate the test environment yourself. That can work too. I'll leave the choice to you. Okay, so I'm going to announce a little bit later about the details you should really watch out for the programming test. But you can mark on your calendar if you're interested. Next Friday, not tomorrow, next Friday. Either you can take it from 5 p.m. to 6 p.m., 1 hour, or you can take it from 6 p.m. to 7 p.m., right? It's a practice, right? I will be there, so if you still want to ask me some follow-up question after that, I'll be happy to stay a little bit longer, okay? Okay, so let's now have a very quick recap about what we covered from Tuesday. I'm hoping to get very close to the end of the review of OOP lecture, and hopefully we can cover some new stuff next week, for sure. So last week, we basically just talked about, sorry, let me just get back here. Yeah, we first talked about the use of accessors versus mutators, right? You really want to watch out for how you're going to use that differently. When is it going to trigger compilation errors? And when it's not triggering compilation error, but it's not very useful, right? You want to make sure you review them. And we talk about the design of method parameters. We will have some other chances to see different possibilities. So just remember, those are just principles for you to try and apply. And we talk about how you can copy the values, and especially for primitive type. And we talk about how you can trace the array and loop iteration, right? That's something we also expect you to know from the first year. If you are still having trouble, practice the kind of tracing I did in class and see where you might get stuck and reach out for help, right? I'm pretty sure you will see something like this in the written test and in the exam. You want to really get prepared for that. And we talk, yeah, that's just an example we saw. And then, yeah, we talk about primitive value copy versus reference value copy, about redirecting the arrow, right? You want to make the difference between them. And that's really the example that we did in detail, right, for the remaining session on Tuesday. And we talk about many details over there. You should really review them, about how to create the array in different notations and how to redirect the arrow in different ways, right? That's basically the end of Tuesday. Do you guys have any questions related to what we said last time? You would like me to clarify, repeat? I don't mind. Anything you want to ask me about before we move on? Don't be shy. All right. Or you got questions, right? Gotta be, go ahead. What question do you have?
For this here, so when you did persons 1 to less than age 70, and then you system out put line Alan dot get age 70, which makes sense because Alan's the first person. But then when you do system dot out put line persons 2 0 dot get age at 70, but isn't the persons 2 array list separate from person 1? So
no, we're gonna look at the diagram. So here you can see persons 2 at index 0. So persons 2 at index 0 is also pointing to the same object. That's what we call aliasing. So both Alan and also persons 2 at index 0, they're pointing to the same objects. So now if we say persons 2 at index 0 that get age, he's going to get the age of the same person, Alan.
So then why for the second one does it stay 70 when it says persons 2 0 get age of 70, but then you change it to 75?
That one's for later, right? So we kind of execute this one first. This one, at this point, is going to be 70,
Yeah, okay.
right? Yeah, but later on, if you change the object structure later, it's going to be different. So I would suggest, because at this point, the reason that it will become 75 or somewhere later is because we redirect the arrow and change the object differently. That's why you're going to get different answer. Yeah, just remember, every time you try to trace an OO code, you got to go line by line. And then whatever output you might have right now in this line, it might change even if you just do the same line several lines later. Because between these two identical lines, you might do something that modify the object structure. So that's why they might be different. They don't stay the same always. Yeah?
So say you initialize the person 1 array and the person 2 array, and somehow you were able to destroy the person's 1 array. Would the person's 2 array still point to the node addresses of the
Okay, I roughly see what you're trying to say here. Let's say this. The answer is no, they are independent. Okay, but let me sketch a little bit. I think it's a good question here to maybe make a short conclusion here. You know what? I'll put it under today's notes so everybody can still refer to it. The question basically goes a little bit like this. That's it. But when you say destroy, maybe you meant maybe assign maybe some object to null. That's as if, right? If you're storing null address, you're really destroying it, right? How about this? Let's say we got person array P1 equals new. You know, person's array. The remaining part will just be valid syntax, okay? I'll let you complete that one. Person, also P2, let's say also a new array, right? You can complete the rest. So after this point, what we have is P1 is pointing to some array over here, and P2 is also pointing to another array that's separate because we got two separate new keywords, new and new. That's all good. And let's now do a little bit of redirecting of the arrow by copying address. Let's say I want to do P1 is assigned to P2. Okay? We're copying whatever that's stored in P2 into P1. So P1 right now, rather than pointing to here, is now going to point to over here. Okay? I guess your question goes more or less like this. Now let's say I want to destroy P2. Let's say. If I say P2 is assigned to null, that means I don't want P2 to point anywhere. It will be as if I want to destroy P2 itself. Okay? Now, after this, if I say print P1 Oh, how about this? I'll make it a little bit more useful. Let's say after this, if I try to print out these two Boolean expressions, I can say P1 equals null, P2 equals null, and also P1 equals P2, right? I got 1, 2, and 3. Okay? Notice that the change I did was P2 is assigned to null, right? What about number 1? P1 equals null. True or false? False, okay? And even before we answer the question, you think about how the diagram should be changed. So here, after saying P2 is assigned to null, you're basically saying this arrow here, rather than pointing to here, is now going to point to null. Now, it's very important for you to know that when you redirect P2, you don't really change P1. P1 stay the same. They are separate addresses to be stored, separate variables. So now after this, all the question will be straightforward. Now P1 equals null? No, because it's still pointing to somewhere. P2 equals null? Yes, because that's exactly what we did. So that'll be true. And P1 equals P2? False. One is null, the other one is not null. I think this will be another example to show to you. You can also do some reassignments for an array variable. You just have to know how to redirect the arrow on the diagram. Okay, question?
In this case, what is P1's value at this time? What is P1's value at here?
P1 is actually pointing to, if you see the diagram, so P1 is pointing to the starting address of this array. So whatever, if you try to print out in Eclipse, it's going to print out the address for the beginning of the array. That's why.
So it has the address has P2's old address before you change it to null.
So P1 will still be pointing to this array, even though you assign P2 to null. It doesn't change P1 at the same time. Okay?
Show an address for P1?
Yeah, of course you can show the address of P1. You just point it out. Or you can put a breakpoint and show in the debugger. Okay? Got to follow up? Got to be quick. Yes. You okay? Okay. Can I answer your question, right? I hope. If not, we can discuss after class. Okay. All right. Okay. Any other question you want to ask? All right. If no, I want to have another quick page just to show to you. So this is the kind of the diagram you can kind of expect to trace, about your OO code. And this is just another example here, similar to what we did last time. But let's say this is what we have. Okay? Now, we want to talk about aliasing. Aliasing is really about when you have multiple variables storing the same address. Multiple variables storing the same address. That would be the very precise definition. But diagrammatically, you're basically saying we might have different pointers pointing to the same objects. That's a diagrammatic way to say it. Okay? Now let's look at one occasion, or one instance of, let's look at one instance of aliasing. We got many instances of aliasing actually, because we got, for example, this object here, there are many arrows pointing to it. Also, there are many arrows pointing to this object as well. But let's look at only one object. Why don't we look at this object here? Okay, I can just modify the question itself. So rather than considering Alan, why don't we consider Mark, right? How about that? Okay? How many path expressions can you come up with that will point to the object's mark? How many? 3? How did you tell? It's 3.
According to the diagram, we have the index 1 of the array, persons 1.
Yeah, true. Yeah, you can kind of see where the arrow goes, right? So there are more concise answers. I'm pretty sure that's what you meant. Look at this object here and see how many incoming arrows you have over here. So that may be the easiest way for you to tell. Okay, good. So let's now take a look. So the answer will be, we got 3 of them. So this will be number 1, number 2, and also number 3. All 3 arrows will point to the same object, meaning that the sources of those arrows store the same address, which will be the mark objects. Let's write them out. So the first one will be just mark. Right? You can see this one here, just mark. What about this arrow here? It would be persons 1 at index 1. So it would be persons 1 at index 1. What about this arrow here? It would be persons 2 at index 1. And we can do some follow-up checks over here. What you can do is, okay, given these 3, you can try to compare them. If you say mark equals persons 1 at index 1, that should give you true, because they refer to the same objects, right? Let me just do one more. If you do persons 1 at index 1 equals persons 2 at index 1, that will also give you true. They also refer to the same. On the other hand, let's give you one example where it's going to be false. If I say, how about persons 1 at index 1 equals persons 2 at index 2. Would that be true or false? False, right? The way to judge it, again, look at the diagram. Persons 1 at index 1 pointing to this object. Persons 2 at index 2. Persons 2, index 2 pointing to this object. This and this are not the same object. So, false. Once you know how to draw the diagram, correctly draw it, answers should not be that difficult to figure out. So that will be my conclusion for that particular exercise. Make sure you know how to draw the diagram. Every time you create objects, perform any variable reassignments, and whenever you are being asked any question related to the codes, about the code, about the variables, you should look back to the diagram. Okay, that's a lesson we learned. Any questions about this? Good. Let's now move on. All right. So we talk about this. And the next one will be just about Java data types. Just talk a little bit more about how you can use a reference type in your Java code. You may actually declare some attributes of reference type, or it may actually got parameter itself is a reference type. So this example here about spouse and person, I will talk about it in more detail after anonymous object. So bear with me. But at least these 2 bullet points are just showing to you, whenever you're declaring any attributes or any parameter, you can you should really declare it as reference type whenever necessary. It's allowed. What I want to discuss in detail is about return values. For return values, it is also possible to have reference type. Can you just stare at this fragment of code over here just for 1 minute? And then I'm going to show you how you may use it and also trace it. You may have to do something similar in your lab later. Okay, stare at that piece of code just for 1 minute. And one check for you, for yourself. This is a mutator. This is an accessor. Right? They have very similar names, but they do something not so the same. Okay, that's something you can see. And one is calling the other one. All right, another 20 seconds. And also, there's another way you want to train yourself. Whenever you're seeing some new methods to you, also want to think about how am I supposed to call that? Once I call the methods, how am I supposed to trace it, right? That's always a question you want to keep asking yourself. Okay, 10 more seconds, and then we'll do a little bit tracing. All right, at least everybody has some familiarity with the this class here. Let's now take a look, okay? So we have this point class over here. And we have the mutator returning void. We have the accessor returning an object. I'm going to focus more on this one here. That's more interesting to see what's really happening, okay? Especially step into this method. This mutator is easy. You simply just move up the points by a certain value. If I have a point over here, if I want to move it up, I will increase its y value to here, right? Basic. And this one here is to say, if I have, for example, let's say P1. If I say P1 dot move up by, let's say 2, just for example. If I have this method call, it does not really modify P1 because it's supposed to be an accessor. As we said before, your accessor should really return something about the context object, in this case P1. So it should not really modify P1. Instead, that one there is going to return a new point object. All right, that's what we're going to see. But that's a very quick sketch. Let's now take a look at how we can trace this piece of code that's going to use these two methods. Let's now just trace it. Line number 1 here. So we got a new object P1, reference variable storing the address of new objects. 2.5 minus 3.6. So P1 is pointing to a point object over here, right? And you got a point, and you got x and y. 2.5 and minus 3.6, right? We talked about already how to trace the constructor in detail. So for that part, I'm going to skip, right? If you're not so confident, you should also try to do that by yourself to convince. The second line, P1 that move up. So P1 now is the context object, this. So if you want to trace it, you can step into move up over here. Every occurrence of this is going to be replaced by P1. And the argument 7.8 over here is going to substitute the parameter. Right? So what we are really doing here is to say P1.y, P1.y, this value here is going to be incremented by 7.8, which will give us 4.2, I believe, right? That's what we're going to do. So this is really matching the spirits of a mutator, because when you call this mutator on the context objects, we really have just modified some attributes of the context objects, which is good. All right? I work with this, right? Not too complicated just yet. Let's now see the third line, which is interesting. We now have basically, we are calling P1 as a context object, but now rather than calling a mutator on that, we're calling an accessor on that. Okay, let's see. So let's now pay attention to this. If you look at this right-hand side, this one here is going to return, according to the API, a point. It's going to return the address of a point. And then we're going to store the address into P2. This one here is going to return the address of some point objects. Once we get the address as the return value, we're going to store that into P2. That's what we're going to do. Okay? And why don't we step into this method here? And whenever you want to step into the method, think about what's this and what's the parameter that's being substituted by arguments. What's this? P1. Agree? So every occurrence of this will be replaced by P1, context objects. And then we have the 6.4 being the arguments is going to replace the parameter I. So 6.4 and also 6.4. Okay? That's something you should really also do when you're doing tracing. Now we are ready to trace line by line. Line number 1. We are creating a new point. It's like a local variable. It's only within the scope of this particular mutator method. Sorry, it's within the scope of this particular accessor method. So MP is pointing to just a new objects. Also points, X and Y. And what should be its value? Well, we know pretty well already. You can see it's a P1.x, 2.5. P1.y, 4.2. That's a local variable, right? And then let's go to here. MP move up by 6.4. That means MP right now is the this. So if you try to execute this method once more, move up, every occurrence of this over here is going to be replaced by MP. And since now we're doing 6.4, since now we're doing 6.4 over here, also replace the I over here by 6.4. 6.4. Right? We're calling these 2 times. I'm writing these values different colors just to show you. Each color shows you a different time of calling the same method. Right? That's something you really want to convince yourself over and over. What's going to happen? So when we move up, it's going to be this. MP.y is assigned to MP.y plus 6.4. MP.y currently is this, plus 6.4, 10.8, 10.6, right? 10.6. Yeah, we're only modifying MP, right? And we just return MP. So let's now highlight this point here. Return MP. What does it really mean? It returns the address of this MP, this object here. The address is being stored in MP. Where do we assign that address to? P2. So we're going to do this. We're going to have the P2 over here is going to store the address of this MP object. So they are pointing to the same objects. Okay? That's it. A very easy check over here is P1 equals P2. Should be true or false? False, right? P1 pointing to here, P2 pointing to here, different objects. Right? Should be false. Of course, there could be different question being asked. You can ask about the contents P1.x versus P2.y, etc. Right? That's something you can also experiment yourself too. But the main idea for this example here is to show to you, number one, you can have a reference type value for return value. Number two, you may have some local variable that also creates an object that can be returned, in which case you just have to know how to redirect the arrow to that return object. And if you look at the in-lab demo from yesterday, we did something actually more complicated than this. Rather than just returning point, we return an array of points. That's also something you're supposed to know. Okay? So now you got both examples available to you. Any questions about this? Yes?
Sorry, for call remove of methods, we keep using calls of decimal values. And I was just confused because
I see. I see what you mean. Being critical is absolutely good. I think this could be a typo from my side. I think since I use 6.4, right? You're right. So these should be double instead. I like it. I'm going to fix it. Thank you. That's what you meant, right? Yeah. Okay. Thank you. Double. Yes. Of course, if you do this without a cast, the compiler is going to complain, for sure. All right. Any other questions, concern? Go ahead. Yes, you can think about it's more like a helper method because over here, I can even write it down. Move up over here. It's basically calling some existing method so you can reuse its line of code, right? So you can think about this more like a helper method call. Helper method call. Yes?
It's not exactly
Uh-huh.
In general, would it make sense to use helper methods on a JUnit test case or not really?
Oh, you mean the JUnit test case? Okay, so let's say this. I'll answer this briefly. Let's say you have point class, okay? Usually, if you want to have a helper method within the class, they should be declared as private. They should be. However, JUnit test class is just like a normal class. This is a little bit more advanced. So guys, what I'm going to say now is optional, okay? JUnit test class itself is just a Java class. Sometimes you might find that for every JUnit test assertion you have to write, they repeat the same line of code so many times. What you could have done is to write a helper method in your JUnit test class itself and call that. You can feel free to try for your labs and show it to me. I can verify that for you. Okay, but it's optional. Okay. All right. Any more questions? Go ahead.
When you're returning an object from
Yeah. Yes.
have to create the object with the method, or can you like return it anonymously?
Very good question. The question was, apparently over here, because I want to return the reference to point. So the way I did it is by simply creating this MP first and then return its address, right? Because I know I need to do some manipulation on this MP. I cannot just return it right away. So this will be anonymous object that you're talking about. In this case, it wouldn't be that possible to return anonymous object right away because I know I need to do some modification first, right? But anonymous object is the next topic, which we're going to see. Okay. By the way, let me just say a little bit more, and I'll answer the question. What you might be thinking could be this. Can I simply do the following? Let's say I simply want to return, let's say new point, and then this dot x, this dot y, and then this anonymous object itself dot move up. You might be thinking something along the line, I guess. This is not allowed because this expression over here, yes, is a point. However, calling a mutator on the point is not going to return anything. So you cannot return it. You kind of follow the principle we said last time, right? Okay. No. And guys, when I say it doesn't compile, you don't necessarily have to believe me. You should really try on Eclipse too to convince yourself, right? Question? Yes, maybe the final one, and then we're going to move on. Please, go ahead.
Yeah, thank you. So it's about local variables.
Yes.
So within embeds, like usually lots of local variables after moving.
That's correct. You'll lose a local variable after the method scope, yes.
So here, it's like different with the reference variable. We just use the reference.
Okay, good question. The question was, we knew that this MP over here is within the scope of this method only. So that means as soon as this return is done, MP itself will be gone. But the thing is, we already assigned this one to P2. So we still have P2 pointing to this object. So this object will not be garbage collected. Only only MP itself. So that's fine. That's a little bit detail here. So think about all the local variables you have created within your method. After the method call has been terminated, all those local variables will be gone. Yes.
But this case there has already been
They will be discarded. Of course. It wouldn't bother you, so don't worry. Yeah. So you can assume that it will be done automatically, not to be done by you. Good? Go ahead, no problem.
So after the point P2 line is executed in the pointer class, if we create another new point that's P3,
Okay.
we are again calling the same method or same accessor method. The NT would be like a new NT variable object would be created.
Yes, that's correct. So let me, since you asked, why don't we just dive deeper into the example? It's worth doing. What you were asking was something like this. Let's say after this, we can say point P3 equals, let's say P1, let's say. Doesn't matter. You can try P2 if you want to. Moved up by 6.4. Okay, let's say that. What's going to happen is we're going to follow the same procedure as I just explained. over here about this one here. So what's going to happen is we still have this local variable MP pointing to that point object, which will just look identical to this one here. And then we still got an X and Y. And now we are assigning that to P3. So P3 is pointing to that object, right? But of course, MP will be discarded after the method call. So at the end, after adding this line here, we will have 1, 2, and 3 objects. I like that. All right. Let's move on. Okay. Let's now talk about something pretty light, just to show to you how you can use anonymous objects, meaning that objects without any name. Before that, okay, good. So this part of the slides will be assigned reading. However, it's also assigned as reading for you since day one. If you click on this link over here, you're going to see that PDF, right? Make sure you follow through it. If you want to see some demo of how this whole thing works, you can also look at the in-lab demo recording from yesterday. That's also what I did. Okay, all the resources there for you. All right, so this one has been covered. And really make sure you understand when you have a collection, you're going to use a primitive array and also some integer counter. How do they work together? It is so important. Okay, that's something already covered. And let's now talk about anonymous objects. Anonymous simply means unknown or without any name. Okay? And the analogy I like to make, if that helps, is to look at something that does not involve any objects. So let's take a look. And for now, if you can please just focus on just these two boxes, just these two. Okay? Version number 1 for, let's say I want to calculate the square of the parameter. I can calculate this expression here and assign the value to some name variable. And I can use that name for return. So you can think about this particular part over here is what we call anonymous expression. It's an expression without any name. Okay? Anonymous expression. Okay, itself. And if we really don't want this square over here because it has no additional functionality except just to store this value here temporarily. It's not used anywhere else. What I can do instead is just return that value directly. Right? So that's the anonymous objects idea. This is an anonymous expression. Right? All right, so that one should be clear. And now let's try to see what does it really mean for anonymous objects. Let's say we have a method here, getPerson. One way to do it is we can create a new person and store its address into some name, P, and just return P. Right? Again, this expression here is called anonymous objects. Right? If you only look at this expression alone, it has no name. But typically, you can store this address here into some variable, reference variable, and then use that name in your code. If you find that you're only using this variable just for one purpose, just to return, in that way, you can simplify your code by just saying return the new expression directly. That's one simple application. Are we okay with this one here? And I can show you slightly more complicated use, which is not too bad. Good? Yes? Good question. The question was, is it more effective by using anonymous objects? Strictly speaking, a little bit more efficient in terms of the space. Because you can see, if you compare this line here and this line here, here we don't need to create any intermediate variable like a P. Here we have to. So we might have to use a little bit more space over here. Strictly speaking, on paper. In practice, it's not going to impact anything. Even if you have so many variables doing this kind of purpose, it's not going to impact too much, so you don't need to worry. When you guys go to the 2101 data structure course next term, we're going to focus more on the speed of your algorithm, not really too much about space. So for space these days, it's not too much of concern, not too much. Okay? But it's also good to think about it, for sure. Let's now do a slightly more complicated example, slightly. Okay? I'm going to show you different versions of implementing this method here, and then we can gradually go from no anonymous objects to using anonymous objects. Okay, let's see. So we got a programming pattern here. We got orders array, we got integer counter, and we got some mutator over here. Oh, by the way, let me ask you a question. I got add order, the same name. But somehow the parameter order versus string, double, and double. What's the name of this kind of phenomenon in Java? Overloading, right? Okay, good. If you think about overriding, you're wrong. Maybe you're not. But overriding is something we'll talk about when we talk about inheritance. Overloading. Okay? It's called overloaded methods. Let me just write it down. I believe that's also mentioned in some of the slides I assigned to you for reading. Overloaded methods. They have the same names, but you can distinguish between them on their parameter types. And let's now do the longest version without any anonymous objects, and the code might smell a little bit. Okay, let's see. Version number 1. I can say, in order for me to add an order, I want to create an order object based on what I'm given over here. Right? So what I would do is I'm going to say, I want to create some order object and give it a name. Let's say O. It will be new order. And then I can use the N, I can use the P, I can use the Q. Now I can use this name. I can say, now in order for me to update, I'm going to do something very similar to this, right? That's kind of the part of the pattern. For that, I assume you already know. So you can say maybe this dot orders add index number of orders is assigned to O. And also this dot number of orders plus plus. That could be one working implementation. Nothing wrong with it. But there is some scope for simplification to make it a little bit better. A little better in structurally, a little bit more simpler. There are 2 improvements we can do. Let's do one by one. Let's do version number 2. You can see here we got repetition. These 2 lines and these 2 lines are the same. That indicates some smell of your code. Right? How do we get rid of it? We can call some helper method. Do we need to define a new helper method? We don't really have to, because the method is here, right? Why don't we say, rather than repeating these 2 lines, just call this method, reusing it. Okay? So version number 2 is by saying, so I'm just going to say version number 2. You're still going to do this, this line here. But here you're going to say this dot add order. I'm going to call the overloaded version as a helper method. And now I can simply pass O here, because that one there is expecting an order. So version number 1 is going to have line number 1, number 2, number 3. Version number 2 is going to have line number 1 and number 2, reducing 1 line. Okay? One more improvement that we can do. So here you can see the only purpose of this local variable O is by using it in the argument over here. Nowhere else. So there may not be so much point to really keep it over here as a separate variable. So why don't we get rid of it by using anonymous objects? So what we can do is version number 3. We can combine these 2 lines, 1 and also 2. Combine these 2 lines into a single line. What we can do is we can say this dot add order, and then I'm going to put some expression over here. I'm just running out of space, but what you can put is, this expression over here and put it here. Okay, you can see the slides. Also, slide contains the solution. Recap. Version number 1. 1, 2, and 3. Version number 2, by introducing the helper method, 1 and 2. Version number 3, we can do both the helper method and also anonymous objects. Only a single line. You can choose the one you prefer in terms of writing the code yourself. But when you read other people's code, they might go for either version. You should know what they really mean by either version. Questions about this? Anonymous object is actually quite useful. You can feel free to use it in your labs to simplify your code to fewer lines of code. But you want to have some balance, right? If you have too many anonymous objects in your code without any names, it could be hard to really read about the meaning of your code. On the other hand, if you go to the other extreme, if you have to declare a local variable for every object expression, that might be overkill. So you want to strike a balance, really. And the balance is really up to you about some experience. Any questions before I move on? Yes?
So quickly, when we're calling our helper method to reduce the code smell or when we're using this, why I know we use this to indicate that we're talking about this.
Attributes.
Yeah,
Yes. Yeah, okay. So, yeah, it's a good question here. The question was, normally when we say this, we'll follow this keyword. Sorry, let me just reconnect my Apple Pencil. So whenever we say this, followed by the attribute names, we're really referring to the attribute. That one is what we learned before. But here, when I say this.addOrder, I'm basically saying this, again, corresponds to any context object you might call. You might say, for example, Jin.addOrder, in which case this will be replaced by Jin, the context object, right? AddOrder, think about this is simply saying, in order to find this method here, go within the current class. So this AddOrder here comes from just the current class, which is over here. That's what it is saying. Current class to look for the method being called. Okay? Make sense to you?
So is this to reduce, like, if you have a similar name of a method in another class? Or?
I would say this one we don't really have the trouble like a shadowing. It's not really. Shadowing only applies to variables. I think the reason I'm putting that here is it would be helpful when you want to do tracing or think to yourself. I'm saying that if I have, let's say, a member object called Jim, let's say, if I say Jim dot, let's say, AddOrder over here, and then I give some N, I give some P, I give some Q. I know that in turn, it is going to invoke this helper method. That helper method is going to be invoked in the following way. This will be replaced by Jin. In that way, if I want to step into this particular call, I would know. I should really go into Jim.addOrder to trace it. Right? It's really for, in some ways like a documentation. I want to make it more explicit which version of the AddOrder I'm calling. I'm calling the AddOrder from this current class member. Can it make sense? Okay. Yep. Questions? Any more? Let's now do another example here, which is more fun. That would be the trickiest example for today. So if you're not fresh up, you may want to refresh yourself quickly. And then let's now talk about this example. Okay. Yeah, this is just another example. You can take a look. Very similar to what we just said. All right, let's talk about the this reference. So far, we talked about a very elementary use of the this keyword. We just say this.attribute name when we want to break through the variable shadowing. We can say this.method, which I just explained. You can just make it more explicit. You're calling the method from the current class, right? Either way. Let's see how we can use the this keyword in a more interesting way when you want to implement something. Okay, let's see what the problem is. I want you to, again, stare at this class for 1 minute, and then I'll ask you a question. 1 minute. pay attention to the type that we're declaring over here. All right, another 20 seconds. Or think to yourself, what variables are declared as reference type? That could be a nice question for you to check. How many, right? All right, 10 more seconds, and then I can ask you, I can make a remark, and then I can ask you a question. All right. So there are actually 3 reference variables as far as I can see. You can see name is a reference variable, string. Spouse is also a reference variable of type person. And notice that it is okay to refer to the person class while we are developing the person class. It is absolutely allowed in programming. It's also quite common. Okay? And we have a person constructor here, and we have another 3rd reference variable, which is a parameter name. Right? So we got 3 reference variables. Now, I want to add a new method here, mutator. Let's say we want to have a method called Mary. Okay? So let's say if I have a person object here called Jim, I want to say Jim.Mary Elsa. So what should I do? Somehow they should become spouse of each other. But how do we implement this method here? Before that, can I just make sure there's no Jim and Elsa in our class? I don't want to embarrass them. I can change the name. Okay, Jim and Elsa then. Good. How do we implement this Mary method? The Mary method is void, returning void, does not return anything, and it takes a single parameter, person, called other. All right? Now, how do we implement that? You guys can keep your thought, that's okay. I think the lesson I want to show to you for this method here is, in general, it may not be so easy. Let's say you kind of know what the method should do, but you just have no clue what to write in your Java code, which is absolutely normal. Because at this point, it might be too much for you to think about a general solution that's going to work for every input value, Jim, Elsa, Peter, Mary, or whoever. It might be too abstract for you to think about. What you want to do instead in this case is to think about some very concrete example and visualize how the method is supposed to do, and then reverse engineer back to what you should write. That would be what I want to show you for this method here. Okay? Let's take a look. All right, so this one I'm going to leave blank for now, right? We'll do that together. But before we get to this part, let's say I'm like you. I have no clue what to write, just don't know. That's okay, totally normal. What I should do instead is I want to work out some usage, like a use case of this class and this method here to see how they're supposed to work. From there, I might be able to get some insights for me to generalize into the method. Okay? This will be the use case I have come up with. Okay? I have 2 persons here, Jim and Elsa. And you can see that the constructor over here in the beginning, I don't really explicitly initialize the spouse. It's left to be default value, which is none, which makes real sense. A person, when they are first born, they should be born as single, right? That makes sense. Now, let's take a look. Let's say Jim and Elsa. Let's now visualize them. Let's say this line over here, Jim should be pointing to a person object over here. And we know every person object has 2 attributes, which will be the name and also the spouse. The name, also the spouse. The name over here will be just Jim, which is like a string objects. And then we have another object here, Elsa. Elsa, which will point to another person object here. And then that person has the same structure. And also got name and spouse. Name and spouse. And that will be Elsa. And in the beginning, of course, both of them are single, right? So the spouse will be pointing to no. And the spouse over here will be pointing to no. Are we good so far? Okay, now, easy question for us to think about. How are we supposed to change the diagram after we call this method here? Jim, Mary, Elsa. I'm not even talking about Java or any programming language. How am I supposed to change the diagram? That's my question. If I say Jim, Mary, Elsa, what should we change? Should we just destroy these two objects, or should we do something else? Anybody? How about just tell me one thing? Go ahead.
In the given object, the spouse attribute, the arrow wouldn't point to null, it would point to
Elsa.
Elsa.
I agree. Yes, that will be one side of the marriage, right? And how about you say the other one?
I was going to say also have it take the Elsa and point.
Yeah, Elsa, the spouse, should also point to Jim, right? It's like a mutual marriage, right? It better be mutual, actually, right? Otherwise, it'll be not so good. All right, so now we're going to do two things. And I'm going to write it down explicitly so we can work out how to generalize it into code. So step number one. Jim, the spouse, should be assigned to Elsa. That's the first one. So that one is going to make sure Jim, the spouse, rather than pointing to no, is going to point to Elsa. Okay, that's easy. And the second one for symmetry, Elsa, the spouse, is assigned to Jim. And the best way for me to draw it may be something like this. Right? Not pointing to no anymore. Are we okay with this? What we thought about is just on one particular example. And now we should generalize this example into what's going to work for every possible context object and every possible argument value. That's what we should put in here. All right? And in this particular one, I would suggest you identify who is the this context objects and who is the arguments or parameter. Okay, let's start from who is the other? Elsa, right? Just by position. Elsa here, right? Is other. Good. Just by looking at the corresponding position, right? Elsa is really the other. Other here is eventually going to be replaced by Elsa, right? Similarly, how about Jim? Jim is really corresponding to what? Please. This, yes. I'm pretty sure you know. Sorry for pushing you, but it's this. Okay? Once we know what they really represent, now we can generalize the code. What we got to do is, how do we generalize the first action? Rather than, you cannot say Jim, the spouse, equals Elsa. You cannot simply put it here, because Jim and Elsa are not within the scope in the class. There are no such variables. Okay? So now what should we do to generalize this line here into here so that it compiles? Anybody? What should I write? Go ahead. Thank you so much. Because we know that within the scope of this method, what corresponds to Jin and what corresponds to Elsa will make sense, this and other. Okay, let's write it down. So I'm going to write down number one here. This the spouse equals other. Similarly, I'm not going to bother you. Second one, other dot spouse equals, because you can see Elsa here, right? Elsa and Jim equals this. The reason that I said this method here may not be so intuitive for you guys to implement first is because we got this as the right-hand side. May not be that easy to think about. But I think if you try my approach over here, think about some example here and generalize it. That might be a little bit easier. So now let's say you got this written down. You're not so convinced. You can go through the process again. If I try to call this particular method here, according to this definition, this will be replaced by Jin. And other will be replaced by Elsa. And try to look at if these two assignments really correspond to what I think that they should work. If they correspond to it, that means I've done the right thing. Right? Kind of go back and forth and back. Right? Any question about this? Yes.
Can we replace this that's control with an object like new person?
Are you suggesting, let me see, okay? Are you suggesting replacing this by like a new person and then Jin? Okay, sounds like an interesting idea. I can tell you that, number one, this code is going to compile, not a problem, because you're assigning this into a new person. But this is not going to work in general. Because over here, basically what you're saying is, whenever I'm calling this marry method, they're always going to marry to Jin. Even if I say Peter dot marry, Mary will still be married to Jin. You see what the problem is? It's not general enough. Okay? So it's not going to work. So my point is, over here, when you work out this particular example, Jim and Elsa, it's just one example. You cannot use the Jim and Elsa in this general method context over here, because this method here should work for every possible combination of the person. That's why you have to replace them by the other, the input, and also this, the current context objects. Sorry, replace what? You mean to replace the Jim here? You mean here? Replace this? By what? That's kind of awkward, I would say. I can see what you're saying. You just want to create a new person here with the same name as this. It's too much. Why do you want to do that? Why don't you just say this? Because this is really corresponding to the person that's being called, just Jin. Not necessarily. Because, let's say this. If you replace this one by new person, let's say Jin, right? So in this expression over here, you're only initializing the Jin objects. But what if there are other attributes over here that are already initialized for this Jin, but you're not initializing them, so they're not the same objects? It's not going to work. Okay? That one's a little bit more advanced, but it's good thinking, right? It's always good to think about different possibilities. But I can tell you that this will be the simplest and correct way. If you try to recreate some object over here, it's difficult to really create just the right objects. Right? You want to just use Jin over here. Okay. Any question? Yeah, go ahead. Yes. Will it just point to the old object, or will it still create a new object? So are you suggesting, you mean still, you talk about this one here? Yeah, okay, say an example. Yeah. So here, okay, how about this? Think about diagrammatically, this may not be so good. If, let's say we do this, okay, how about I'll write it down here? So here, you're saying rather than this, I'm going to write, let's say, new person. And then Jin. Okay, let's say. Diagrammatically, I'm basically saying, what I wanted to do is marry this person object here to this Elsa objects. But the method will do is create another fake Jim objects somewhere and let it marry to Elsa. Right? It's going to be some new objects over here. Somehow it's also person. And that one there has the name, also Jin. And let Elsa actually marry to that particular Jin person. Does it sound right, right? So how about I keep it here? It's not good, even though it will compile and run. But it's not going to run the way we expect. Okay, so if you don't mind, let me undo this because I might need a little bit more space. But you guys see the idea. If you want to see this particular example that's suggested by your classmate, which is very good thinking, but they were unfortunately not correct. So you want to know why. Let me ask you some follow-up question. I think all is well. We figure out the critical part for this particular method. But now the issue is, sometimes when a marriage is proposed, it may not be a legal one. For example, let's say Jim wants to marry Elsa, but unfortunately, Jim is already married. Well, Jim doesn't even know that Elsa is already married, right? In that case, what should we do? We should somehow signal an error to say, oh, sorry, marriage is not allowed unless you divorce first, something like that, right? How do we somehow address this in this method? And this is what we call a software engineering principle called robustness. Robustness means your method should really think about different scenarios, not just the normal scenario. For a normal scenario that will trigger an error, your method may want to think about it too. Okay? And we're going to learn about how you can signal an error the appropriate way using exception next week. But for now, let's just sketch the code structure a little bit. And there will be some interesting questions we can answer already. Okay? How do we say, if the marriage being proposed is legal, I do this. Otherwise, I do something else. What structure, what syntax should I use? If else, right? Okay, good. I'm pretty sure you know the syntax for if else. Let me do the following. I want to say, if some condition over here, which you got to fill out for me, if that happened, this will be considered an illegal marriage. I'm going to give you some error. And for now, you haven't learned about exception, that's okay. You can say system out the print line. Not accepted or something like that, right? Else, I can do what I did earlier. So you can see the structure here, right? We want to be able to signal an error if the proposed marriage is illegal. And the question is, what should we put over here? And already in the informal description, proposed marriage is illegal. Okay? I'll put a star here. Anybody? What should I put there? Should it be an integer expression, or should it be a string expression, or should it be what expression first? What expression should it be? Boolean expression, thank you. But just before I point to you, now that Boolean expression there is going to tell me the condition which will evaluate to true if the proposed marriage is illegal. It will be false if it is legal, right? What would be your suggestion? I'll go with you first.
So it has to be true if it's illegal, right? So
Yes.
If this, that's house.
I'll write it down. Give me a moment.
It's different than null, so it's
Not equal to null. Yeah. Not equal to.
or sorry, other that's house. Different than
Okay. Interesting. Okay. Any objection to this? If you got other alternative, save it for now. I'm focusing on this one here. Do you agree? If you don't agree, raise your hand. Tell me what you would suggest instead. You don't agree? Okay.
Would this dot spouse is equal null and other than spouse?
That's interesting. I was waiting for somebody to say it. I'm glad you say it. Okay. Why don't we take a look? Okay. So why don't we say we want to decide between or and and. Okay, how about this? Let's be a little bit more informative for us. This one here is really saying this is married. The context object, right? Because its spouse is not equal to noun. Agree? That's just a little bit more straightforward for you to think about. And this one is saying other is married. The first solution, it will be illegal if either this is married or other is married. The second one saying it will only be illegal if both of them are married. Which one sounds more correct? In your case, to say both of them should be married to make the marriage to be illegal. What about only one of them is married, but not the other one? Would that still be illegal? It would, right? Because both of them gotta be unmarried or single. So this one might be not strong enough. Okay, you see what I mean? Okay, good. So I will put this one here to say not enough. You guys really want to convince yourself why this is not enough condition to say it's illegal, right? If you say it's only that when both of them are married, would this marriage be illegal? That's not enough. You want to say either this is illegal, either this is unmarried or the other one is unmarried, right? Question?
There's an operator I forgot the name of it. It's the circle with the cross in the middle, where one of them has to be true, or the other has. Oh, but that doesn't count for both being true. I forgot the term for it. It just means that one of the two cases are true.
Which operator?
It's a circle with a cross with it in the middle.
Exclusive or. Sure. Let me, let's not worry about exclusive or just yet. Okay, good. Okay. And we know that this will be right. And let me just mention one more thing. Yeah. Let me look it up to make sure, and then I may mention that next time. Yeah, I'll look it up. Okay. So guys, this one here, if you get the n% is wrong. Okay. I want to suggest one more thing and one exercise for you. Okay. Have you guys heard about De Morgan before? Does it sound familiar? De Morgan? What is that? Yeah, okay, exactly. Okay. So now in this case, you're basically saying not P or not Q. That should be equivalent to not the case P and Q. Agree? Think about this guy here is not P because we got not, or not Q. We can rewrite this expression here to be something equivalent. Why don't we do that? Just for your information. You can put this one here into something here, alternative. So it would be not the case. This the spouse equals now, and other the spouse equals now. And does this really make sense? This is saying the following. The marriage should be considered as illegal if it is not the case. Both of them are single. Because when you say their spouse is now, they're single. If you really find your brain spinning right now about the logical operator, you want to think about it, right? I'll make it even worse for you. I have an exercise for you. But don't do it now. Okay? You want your brain to rest a little bit. Let's do this one here. I'll propose the exercise for you. So right now, we are basically having the following code structure to say, if this condition here is true, we will consider the marriage to be illegal. Otherwise, we do the normal thing. Let's flip the logic a little bit to say, exercise. Okay, we still have our married method. Person, other. And then void. Okay. Now I'm going to say this. If this condition is satisfied, it will be considered as legal marriage. And then I'm going to do this the spouse equals other. other the spouse equals this. Otherwise, I should somehow signal some error. Now the question is, what should I put as the Boolean condition here? That's your exercise. Think about it, okay? In the test or exam, I might give you some Boolean expression here and give you the code structure and ask you a simple question, is it correct? Or what's wrong? Something like that, right? Think about this exercise. I think it'll be a very nice way for you to also brush up your memory about how to use logical operators, okay? If you got trouble thinking about it, reach out to me. More than happy to engage the question. We've got about 4 minutes. How about we do one more thing, and then I'll let you go. Okay, one more thing. Okay. So this example here is done, and we have done very thoroughly. Oh, actually, you know what? How about we just do one more slide? I think that should be enough. And then we can do static variables on Tuesday. And we should be done, hopefully within half an hour on Tuesday to finish the entire review. Okay, one more slide. A little bit more exercise to do with this example. Let's do it quick. Yeah, about dot notation. Basically, dot notation, just for you to navigate to attributes, to different classes. Let's see, in this example, you'll get more feel about how to use it. Let's assume in the person class, we have a method called name to get a name, and spouse to get a spouse, okay? Let's say we have a Jim person over here. How do we use a dot notation to know about Jim's name? That's an easy one. Jim.name, agree? That one's easy. Now, how do we get the name of Jim's spouse? Easy. Go ahead. Jim.spouse.name. What does that really mean? Jim.spouse.name goes like this. Jim dot spouse dot name is going to give you Elsa. Okay? Now, question for you. In general, if I simply give you this expression here, Jim.spouse.name, you gotta watch out very carefully, because what if Jim.spouse itself is actually null? Here, if we assume Jim is already married, that's okay. But what if Jim is single? In that case, I'm asking you, what's the single person's spouse name? That'd be null pointer exception. Agree? So now what I'm saying is, in this diagram, what if Jim.spouse remains to be null? In that case, you ask me, what's Jim.spouse.name? So Jim.spouse is going to point to null, null.name, null pointer exception. Right? Watch out. Okay? 3 more. Okay? Now, one by one. Okay, easy. How do we express Jim is not single? Jim is not equal to null? Or Jim.spouse not equal to null. Good. Now this one. How do we say the marriage is mutual? In the following sense. Let's say after the marriage, let's say it's legal. Jim.spouse should be Elsa. I want to say Elsa's spouse should also be Jim. How do we say that? But now you cannot use Elsa. Okay? Okay, if you can navigating, right? Now let's think about the diagram here. Jim.spouse is referring to Elsa. I want to say somehow Elsa, the spouse, is also pointing back to Jim, but I can only start with Jim. So I can say Jim.spouse is equal to Jim. Or I can say Jim.spouse equal to Jim. I can also say that. I like to ask you that in the test. So you really got to know what I'm specifying there. All right? It's all legal expressions in Java. All right? All right, final one, please. Final one. What does this really mean? Jim.spouse.name, assuming that there's no null pointer exception. Is it Jim or Elsa? Okay, verify it, and I'll let you go. Please give me one moment. So here, this is saying Jim.spouse.name, which will be Jim. All right, thank you so much. And review the stuff, and then we'll finish the static part next Tuesday. Have a good weekend.